So we are now at power series. So a power series is an infinite series of the form summation ak times the quantity x minus b raised to k, where k goes from 0 to infinity. So we can expand this as a sub 0 plus a1 x minus b plus a2 times the quantity x minus b squared plus a3 times the quantity x minus b quantity cube plus dot dot dot. Now observe that if b is equal to 0, our power series reduces to summation of ak x to the k, where k goes from 0 to infinity. And we can also write this as a sub 0 plus a1x plus a2x squared plus a3x cubed plus dot dot dot. So in general, the power series summation ak times x minus b to the k, so where k goes from 0 up to infinity, converges to, so we have for all x, which is element of R, we have only for a single value b, which is also element of R, and for all x element of R such that the absolute value of x minus b is less than R, where R be element of the set of real numbers, so the positive real numbers. So take note, the largest number R, which is an element of the positive real numbers, such that a power series converges for the absolute value of x minus b less than R, and diverges for the absolute value of x minus b greater than R, is called the radius of convergence of the power series. So it may be determined by the ratio test. So if the value of R is equal to infinity, we can say that the series converges for all x element of R. And if R is equal to 0, then the series converges only when x equal to b. Also, the interval of convergence of a power series is the set of all points for which the series converges. It always includes all points such that the absolute value of x minus b less than R, but may also include endpoints of this interval. So for example, for what values of x is the series summation of x minus 2 raised to k over square root of k plus 1, where k goes from 0 up to infinity, convergent? Okay, so let us do that. So we let uk be x minus 2 to the k all over square root of k plus 1. So if we take the absolute value of uk plus 1 all over uk, we will get x minus 2 times the square root of 1 plus 1 over k all over 1 plus 2 over k. Now if we take the limit k approaches to infinity, so we will get the absolute value of x minus 2. Now, by applying the ratio test, so by ratio test, so the series is convergent for the absolute value of x minus 2 less than 1. So which simplifies x between 1 and 3. Now, we are not done yet. We also check if the series is convergent at the endpoints 1 and 3. So for x is equal to 1, we see that the series is an alternating series. Now to check if this is convergent, we will use the alternating series test, and upon solving, we saw that the series is convergent. Now for x equal to 3, so the series will become this, and upon solving, we saw that the series is divergent. So I use limit comparison test. So we can conclude that the series is convergent for x between 1, and now we include 1, and then x less than 3 but not included 3. So the interval 1, 1, 3 is what we call the interval of convergence. So take note that a power series can be differentiated or integrated term by term over any interval contained within its interval of convergence, and possibly at the endpoints of that interval. For example, find an expression for this integral. Okay, so we all know that this is convergent for this interval. So the interval 2 to 5 over 2 is a subset of the interval 1, 3, So we can able to integrate this expression. So we have 2 to 5 over 2 of the series so we can insert the integral sign to the summation. So we will have summation so integral 2 5 over 2 x minus 2 to the k over now upon solving this we will get summation of 1 over 2 raised to k plus 1 all over k plus 1 raised to 3 over 2 where k goes from 0 up to infinity. So this is your final answer. Okay, so let's have the Maclaurin series. So the Maclaurin series have the form f of 0 plus f prime 0 of f prime of 0 of x plus f double prime 0 all over 2 factorial times x squared plus f of triple prime of 0 all over 3 factorial x cube plus dot dot dot, or in summation notation we write it as in this form. So provided that f prime of k of 0 exists for k be element of the natural numbers. And then we have the Taylor series, so which has the form f of a plus x minus a times f prime of a plus up to this term plus dot dot dot, or we can write it in this summation notation form. So provided that f to the k of a exists for k be element of the natural numbers. So observe that if a is equal to 0 in the Taylor series expansion, it will give you the Maclaurin series. So for example, find the Taylor series expansion for the function e to the x. So to do that, let us first find all the derivatives of the function. So f of x equal to e to the x. So if we do f prime of x, you will get e to the x. F double prime of x, you also have e to the x until we have the kth derivative. Now, if x is equal to 0, so we have 1, f prime of 0, we also have 1, f double prime of 0, so 1 until f to the k derivative of 0, so we have 1. So we can now write the Taylor series expansion for e to the x. So we will have f of e plus f prime of a times x minus a plus f double prime of a all over 2 factorial x minus a squared plus f triple prime of a all over 3 factorial x minus a cube plus and so on and so forth, or we can write it as summation k goes from 0 to infinity of f to the k derivative a all over k factorial, and then we have x minus a to the k. So I'll write it again, the Taylor expansion. So we have this a k factorial 0 to infinity x minus a raised to k. So this term would be e to the a. So the final expression would be e to the x is summation k 0 to infinity of e to the a over k factorial x minus a to the k. Now, if a is equal to 0, so e to the x would be x to the k all over k factorial. So this expression is the Taylor series, and this expression is the Maclaurin series.